In this tutorial, we are going to discuss the derivatives using the definition of the derivative. So, just recall about the derivative definition, which is given as f dash x is equal limit h tends to 0 f of x plus h minus f of x over h. So we'll take different function and we'll establish the derivative of those functions. So first example, we will take it f of x is equal x square. So to find the derivative for this function, so we have limit h tends to 0 f of x plus h minus f of x over h. This is equal limit h tends to 0. So f of x is equal x square. So this will gives you f of x plus h will be x plus h whole square. So this we'll write it here, x plus h whole square minus x square over h. So here you can solve it two way, either use the formula a square over b square, or you can just open up the bracket. So this will be 2xh plus h square minus x square over h. Now this x square will cancel out. You will get it. This is equal limit h tends to 0 h 2x plus h over h. H vanish. So you will get it here. This is equal limit h tends to 0 2x plus h, which is equal to x. So this implies f dash x is equal to x, or we can write t dx of x square is equal to x. F of x is equal e to the power x. So to find the derivative, we'll have to do this limit h tends to 0 f of x plus h minus f of x over h. This is equal limit h tends to 0 e to the power x plus h minus e to the power x over h. E to the power a plus b, this can be written as e to the power a e to the power b. So this is, you can write it here, limit h tends to 0 e to the power x e to the power h minus e to the power x over h. This is equal e to the power x limit h tends to 0 e to the power h minus 1 over h. This limit is a standard limit and this is equal 1. So this will gives you e to the power x multiply 1 is equal e to the power x. So therefore d dx of e to the power x is equal e to the power x. Our next example is f of x is equal sin x. In this case, we have to calculate limit h tends to 0 sin x plus h minus sin x over h. So we can use two methods to expand this. So this can be written as limit h tends to 0 sin x cosine h plus cosine x sin h minus sin x over h. This is equal. Separate into two parts. H tends to 0. Cosine x sin h over h plus limit h tends to 0. You have here sin x and then cosine h minus 1 over h. Sin h over h is equal to 1. So you have here cosine x and limit h tends to 0 sin h over h plus sin x limit h tends to 0 cosine h minus 1 can be written as minus 2 sin square h over 2 over h over 2. So this is equal cosine x multiply 1 plus sin x. So it's not plus, we will take out the minus. So this will be minus. This can write it, okay, sorry, this is h. So then you have here limit h tends to 0 sin h over 2 and limit h tends to 0 sin h over 2 h over. So final step we will get it here cosine x minus here sin x. This is sin 0, this is 1. So sin 0 will be 0. So you will have here cosine x. So therefore d dx of sin x is equal cosine x. We'll discuss now method 2 where we'll use this formula sin a minus sin b is given by 2 cosine a plus b over 2 and sin a minus b over 2. So in this case a is equal x plus h and b is equal x. So therefore a plus b over 2 is equal 2x plus h over 2 x plus h over 2 a minus b over 2 is equal h over 2. So we can write this is as limit h tends to 0 cosine 2 cosine x plus h over 2 and sine h over 2 over h. So this will gives you limit h tends to 0 cosine x plus h over 2 sine h over 2 over h over 2. So this is equal cosine x plus 0 limit h tends to 0 sine h over 2 over h over 2 which is equal 1. So you have cosine x multiply 1 is equal cosine x. F of x is equal cosine x. In this case limit h tends to 0 cosine x plus h minus cosine x over h. So this is equal limit h tends to 0, cosine a plus b, this will give me as cosine x cosine h minus sin x sin h minus cosine x over h. So this is equal limit h tends to 0, cosine x, and then cosine h minus 1 over h minus sin x, and then limit h tends to 0, sin h over h. So here, as previously I show you that this limit will goes to 0, so you will have cosine x, and this is 0 minus sin x, and this is 1, so you will get it here minus sin x. So therefore d dx of cosine x is equal minus sin x. Next example, f of x is equal x plus 1 over square root of x. So let's first separately calculate f of x plus h minus f of x. This is equal x plus h plus 1 over square root of x plus h minus x minus 1 over square root of x. So if you combine these two, then you will get it h plus, here you have 1 over square root of x plus h minus 1 over square root of x. Then we will h plus, here you have square root of x and square root of x plus h. So you have square root of x minus square root of x plus h. So for future purpose, we'll just multiply with the conjugate and we will keep simplification. Square root of x minus square root of x plus h, square root of x plus square root of x plus h over square root of x plus h. This is equal h plus, you simplify this numerator, you will get it here x minus x plus h over square root of x square root of x plus h square root of x plus square root of x plus h. So we'll get it here h minus h over, so therefore f dash x is equal limit h tends to 0, h 1 minus 1 over square root of x plus h, and square root of x plus square root of x plus h over h. So this h and h cancel out, then you will get the limit as 1 minus 1 square root as it is x plus, and here you have a square root of x plus 0. Simplify, 1 over 1 square root of x, and here multiply 2 square root of x. So 1 minus 1 over 2 x square root of x. So therefore d dx of x plus 1 over square root of x is equal 1 minus 1 over 2x square root x. If dash x is equal, limit h tends to 0, x plus h plus 3 whole square minus x plus 3 whole square over h. This is equal limit h tends to 0. You will have 2x plus h plus 6, and then you have h over h. So this h cancel out, so you will get it here. This is equal limit h tends to 0, 2x plus h plus 6. So this is equal 2x plus 6.